All right, so another key thing that we need to talk about is hydraulic head and hydraulic gradient, okay? So hydraulic head is simply the height to which water will rise in a well in that area, okay? So here, for example, since we have the well down into a down into a confined aquifer, and we have the potentiometric surface above the mouth of the well, we can't measure that because it'll flow out onto the ground. So what we do is we look at the pressure. So the hydraulic head is simply the elevation of water that it would rise to in a well if it was present. So here, is the hydraulic head higher or lower than here? Is the potentiometric surface higher or lower than here?
Isn't that equal?
I thought it was not here.
Not quite, no. As we move away from our recharge zone, the potentiometric surface lowers. Okay, so we have a slightly lower potentiometric surface here than we do here. That means we are going to have a higher pressure here than we do here. This is why water flows in the direction it does. We always say that water flows downhill, right? Well, that's not exactly true. Underground, water flows down pressure gradient. So the pressure gradient, or the hydraulic gradient, is going to be the difference in pressure between one point and another. So because we have a higher pressure here and a lower pressure here, we have water flowing in this direction. Even though we have water underground, it's still going to flow up and out of this well because the pressure here is higher than the pressure here, right? At two different points. So that's how we can actually have water flowing up and out of this well. So we have hydraulic head, which is the pressure, hydraulic gradient, which is the difference in pressure. And water always flows down hydraulic gradient.
So with the unconfined aquifer, how does the water, like, what makes it flow? Like what?
So in the unconfined aquifer, it's the same thing. Here we have a specific hydraulic head, and here we have a specific hydraulic head. Whichever one is lower is the direction the water will flow. And this is a 2D model, so it's very easy to visualize. When you get into a 3D model and it's a plane or surface that has different, bumps and ditches in it, then it's really, really difficult. And we're not going to really get into that. But the same is true that any fluctuations in the groundwater table are going to tell us which direction it's going to flow based on the difference in pressure.